Flyby mission. A flyby mission is the simplest kind of lunar mission, but it was the first real step toward landing on the moon. In this type, a spacecraft travels to the moon, swings around it using gravity, and then returns to Earth without entering lunar orbit or touching the surface. Early missions, like the Soviet Luna 1 and Luna 3, helped scientists understand the moon up close for the first time. Luna 3 even captured the first images of the moon's far side, something no human had ever seen before. Flyby missions matter because they are less complex and use less fuel, making them ideal for early exploration and testing spacecraft systems. Even today, flybys are useful for gathering data and testing new technology before more advanced missions.
Orbiter mission. An orbiter mission goes one step further by entering the moon's gravity and circling it for days, months, or even years. Unlike a flyby, it stays around the moon to study it in detail. These missions map the surface, measure temperature, scan minerals, and search for water ice. NASA's Lunar Reconnaissance Orbiter is one of the best examples, still providing detailed images of landing sites and hidden craters. Orbiter missions became important because they gave scientists a complete picture of the moon before humans attempted landing. They also helped choose safe landing spots for future missions. In modern space exploration, orbiters act like observers in the sky, collecting information that landers and astronauts can use later.
Hard landing mission. A hard landing mission is when a spacecraft reaches the moon's surface but does not attempt a safe touchdown. Instead, it crashes into the surface on purpose or because landing technology is limited. In the early space race, many countries used this method to prove they could reach the moon at all. The Soviet Luna 2 became the first human-made object to hit the moon in 1959. Even though it crashed, it was a major milestone. Hard landing missions can still be useful because instruments may collect data during descent, or the crash can reveal underground material. They are simpler than soft landings, but they are not designed for long-term study on the surface. Soft landing mission. A soft landing mission is designed to touch the moon gently and survive the landing first. This is much harder than a hard impact because the spacecraft must slow down at exactly the right time. The Soviet Luna 9 became the first successful soft landing in 1966, proving that landing safely was possible. Soft landers carry cameras, drills, and scientific tools to study the moon directly. They can examine soil, temperature, and even seismic activity. Soft landing missions changed lunar exploration because they allowed scientists to work directly on the surface instead of only observing from space. Today, most robotic lunar exploration depends on this mission type. Sample return mission. A sample return mission is one of the most valuable types of moon missions because it brings actual lunar material back to Earth. Instead of studying the moon remotely, scientists can examine rocks and soil in laboratories with advanced equipment. The Apollo missions brought back hundreds of kilograms of lunar material. And later missions, like China's Chang'e 5, continued that effort. These samples revealed the moon's age, volcanic history, and possible connection to Earth's formation. Sample return missions are complex because they require landing, collecting material, launching back from the moon, and safely returning home. But the scientific value is enormous because real samples tell stories that remote sensors cannot. Crewed landing mission. A crewed landing mission is the most advanced and challenging type of moon mission because it carries human beings to the lunar surface. NASA's Apollo program remains the most famous example, with Apollo 11 making the first human landing in 1969. Humans can move, adapt, and make decisions in ways robots cannot. They collect samples, set up experiments, and explore more freely. Crewed missions require life support, safe landing systems, and a way to return astronauts home. These missions matter not only for science, but also for human progress, proving that people can travel and work on another world. Future missions under Artemis aim to continue that journey. Rover mission. A rover mission adds mobility to lunar exploration
by allowing machines to travel across the surface instead of staying in one place. Some crewed missions, like Apollo 15, carried lunar rovers driven by astronauts, while modern robotic missions are developing autonomous rovers. Rovers can explore wide areas, inspect rocks, and reach places a lander cannot. They are especially useful for studying craters, hills, and shadowed regions where water ice may exist. Their wheels, cameras, and sensors turn them into moving laboratories. Rover missions matter because the moon is not the same everywhere, and traveling across its surface reveals a much bigger story about its history.
Cargo delivery mission. Cargo delivery missions are built to transport equipment, supplies, and technology to the moon without carrying astronauts. These missions are becoming more important as space agencies prepare for long-term lunar bases. Instead of focusing only on science, cargo missions may carry habitats, power systems, food, or vehicles. Companies working with NASA under commercial lunar programs are already planning these deliveries. The goal is to build infrastructure before humans arrive. Cargo missions are different because their main purpose is support, not exploration. In the future, they may become as common as supply missions to space stations, making human life on the moon more practical.
Base building mission. Base building missions are the next major step in moon exploration. Instead of short visits, these missions focus on creating a permanent or semi-permanent human presence. They may include building shelters, power stations, communication systems, and mining equipment. Future Artemis missions and international lunar programs are centered around this idea. The moon's south pole is a major target because of its water ice, which could be turned into drinking water, oxygen, and fuel. Base-building missions matter because they turn the moon from a destination into a working outpost. They could become the foundation for future journeys to Mars and deeper into space.